Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics, unit number 8, chemical bonding, series number 4 is going to be discussed. In this session, scientific perception regarding Lewis and Kossel, and in addition to that, Octet Rule is going to be discussed with the relevant examples. So earlier we completed what are the kind of forces operating in chemical bond formation and what is Lewis dot structure and what kind of reasoning questions are covered. All these are discussed in the earlier session. In addition to this, unit number 1 to 7. So this detailed explanation available on the channel called World of Competitive Chemistry. Let us enter into our series number 4 of this unit 8. Here, electronic theory of valency by Lewis and Kossel. So this is a new kind of perception which is given by the combination of Lewis and Kossel, which is said to be an advanced theory, where there are a number of attempts to explain the chemical bond formation between atoms in terms of electrons, but satisfactory explanation was given by Kossel and Lewis in 1916. So many theories were there, but most relevant theory will be Kossel and Lewis, so that it is widely accepted one. They gave this concept independently. Basis for this theory was a valency in terms of electrons. Based on the valency electrons present in the atom, type of bond will depends. When you go with sodium, by losing one electron, then only formation of Na positive, and it will attain the noble gas configuration that is Na2NP6. And in the similar manner, chlorine with the outermost electrons Na2NP5, which used to gain the electron so that it turned into Na2NP6. This is the electron which is gained by the process called a reduction, so that it turned into Na2NP6 and again it will attain the noble gas configuration. In this manner, here always the tendency seeking or gaining of electron purely depends upon the kind of valency electrons present in their outermost shell with respect to the central nucleus, right? So this is a kind of nature which purely attained by their valency electrons. Which atom tends to lose the electron and which one will gain the electron? How can we assume which is losing and which is gaining electrons? That is purely based on its valency electrons. The ultimate goal will be in order to attain the noble gas configuration. This is given by Lewis and Kossel, electronic theory of valency. And they provided the logical explanation valence on the basis of lack of chemical activity of noble gases, which led the proposal of Octet Rule, right? So in order to explain that why some of the species are losing and some other species gaining electrons, why noble gases are inert and very stable in nature, in order to explain all this, one scientific rule was framed that is called the Octet Rule, right? So here, in order to explain the Octet Rule, we have to go with all noble gas elements, which are helium, neon, krypton, argon, xenon. All these corresponds to the noble gases, where outermost shell is completely filled with the Ns2Np6 electronic configuration, and except helium, where only two outermost electrons are present. Octet rule is nothing but all noble gases except helium are attaining Ns2Np6. 8 electron. Octa means, in accordance with the IU path, octa means 8. So 8 electrons will be there in outermost shell, which corresponds to the higher stability. Octet rule gives that atom tends to gain or lose the or share the electrons until it used to attain the 8 valency electrons in their outermost shell. Carbon, nitrogen, oxygen, fluorine always obey the Octet rule. That's the reason why they used to find in the combined form, because then only there is a they used to tend to convert into octet configuration. Outer atoms obey the Octet rule. Caution: there are many exceptions for this Octet rule. So many compounds tends to obey this one. A few exceptionals also present. This is the advanced theory which is given by Lewis and Kossel in accordance with the electronic theory of valency, right? So what is meant by octet? Observe the practical behavior of atoms which are present in the main group elements. If you go with the first A, whose outermost configuration is 1s1 or n-is1. Second A, n-is2. Third A, n-is2, np1 is the general electronic configuration. Fourth A, n-is2, np2. Fifth A, Ns2Np3. Sixth A, Ns2Np4. Seventh A, Ns2Np5. And inert are noble gas elements, Ns2Np6. These are the general trends which you can clearly observe in these Roman numerals which are present in the different groups. All these are collectively called as the main group elements, and first A, second A are called as block, and remaining all are collectively known as a P block elements. When they are allowed to undergo the chemical changes, they try to get the octet configuration in their outermost shell. What is octet? Ns2Np. 6 electronic configuration. This is known as octet, where 8 electrons are required in their outermost shell. Then they will get the stability. Now, let us understand the following illustration by taking first A group element either lithium, or if you are moving towards it down, that will be up to cesium. Any one of the element of alkali metal, all these are the first group elements, and having strong tendency to lose one electron, and in order to attain the unipositive charge, because only one electron will be lost here, you can clearly observe the configuration will be 1s2, 2s2, 2p, 6, 3s1. This is for sodium. I am taking the simplest example, sodium, so that here outermost shell having only one electron. That's the reason why it having strong tendency to lose that, and Ns2Np6 configuration octet will be achieved by converting into a unipositive ion in accordance with this octet rule. Now, move on to second group, where second group elements ranges from beryllium, magnesium, calcium, barium, radium. All these are the elements which are grouped in a second, and try to lose the valency electrons. How many? 2 valency electrons will be lost by this alkaline earth metal, so that they converted into a dipositive cation. And when they are losing 2 electrons from outermost, because Ns2 is the outermost configuration. If these 2 electrons lost, again there is a possibility of noble gas configuration. With respect to the central nucleus, here magnesium is containing 1s2, 2s2, 2p6, 3s2. When 3s2 electrons removed, that will become 1s2, 2s2, 2p6 itself, because of this outermost shell will be lost by losing 2 electrons, so shrinking in the size is possible, and magnesium dipositive will be converted into a smaller. Then it will be more stable. So in this manner, second group elements are attaining by losing 2 electrons, and dipositive cation will be generated in accordance with Lewis and Kossel. And move on to third A group. In accordance with the Roman numerals, we are moving. Otherwise, in modern IUPAC nomenclature, you can say it is a 13th group, right? So Arabic numerals, it is represented as a 13th group. In 13th group, they try to lose 3 electrons because valency electrons are 3. Ns2Np1 is the general electronic configuration, where I'm taking the generalized example, aluminium, whose outermost shell is composed of 1s2, 2s2, 2p6, 3s2, 3p1. Means 3s2, 3p1, these 3 electrons are collectively known as a valency shell electrons, because this is the outermost shell. Third main shell is the outermost, where 3 electrons are having capability to lose, so that aluminium tripositive. They are used to tend to get a tripositive, and here you can observe 3 dots here. Means 3 electrons lost from the outermost valency shell and attaining the noble gas configuration. This is also explained by this advanced theory called Lewis and Kossel electronic valency, electronic factors influencing the valency. And move on to fourth group elements. I'm taking carbon family, where it is mentioned as 14th group in accordance with the Arabic numerals, and they having tendency rather to release, they having tendency to gain 2 electrons to their valency shell, and this is a kind of 6th. So this is not 4th group. If you consider 4th group element, that is the carbon. So what is the tendency that used to form the 4 bonds? So here Ns2Np2 is the general electronic configuration, short of 4 electrons in order to achieve the outermost configuration of octet rule, so that carbon is tetravalent and 4 bonds will be generated. And this is accordance with the 6th group oxygen family, where short of 2 electrons are there in order to achieve the octet, so that there is strong tendency to gain 2 electrons With respect to central nucleus, its configuration will be 1s2, 2s2, 2p4, means short of 2 electrons in order to get 2p6. More 2 electrons are needed, so that strong tendency to gain the electrons. So after when we compare the electronegativity of all the elements, after fluorine, oxygen will be the more electronegative, and it will having tendency to seek the electron and convert it into di-negative anion. You can say -2 is called di-negative anion. So here, what happens? More 2 electrons will be added here. You can clearly observe in case of this O-2 NS2 NP6 configuration, that is the completely octet is achieved and it will become more stable. And move on to 17th group in Arabic numerals, Roman numerals, it will be a 7th A group. When we consider the 7th A group, I'm taking the simplest example, fluorine, where 1s2, 2s2, 2p5. In order to get 2p6, how many electron difference is there? Only 1 electron. Whether gaining or seeking, always it has strong tendency to seek the electrons. So gaining and seeking both are same. Gaining or losing means here a strong tendency to gain the electron will be there, so that electron will be gained and converted into uni-negative anion, right? Uni-negative anion is generated and it will become the octet. F minus will be octet. F is violating octet with a short of 1 electron. That's the reason by strong tendency to gain the electron. Hence, you can say fluorine is the most electronegative element in the entire periodic table, having strong tendency to gain the electron. So this is about 7th A, otherwise 17th group of this periodic table. And again, it is a valency, which are exactly related with the octet. So that here, Lewis and Kossel generalized the concept to all the groups. All are obeying this concept, going to attain that noble gas configuration in general. And we entered into a noble gas configuration, that is what 18th group elements we are considering. Then you may say it is the 8th A group as well, where noble gas is having neither to lose nor to gain the electrons, because already completely satisfied electronic configuration will be there. 1s2, 2s2, 2p6 in case of neon, 10 electron system, and outermost shell with the 8 electrons, most stable configuration will be assigned for this element. That's the reason why it is more stable, inert, and monatomic in nature. And this will be the generalized configuration, so that it is not participating in most of the chemical reactions. So this is also purely explained based on its octet rule. Now we are categorizing all the elements based on their valency. Otherwise, electron gaining or losing tendency, right? What is the general tendency of non-metals? Non-metals having general tendency to gain the electrons, metal having general tendency of losing electrons, and noble gases neither to lose nor to gain the electrons. They are neutral. Noble gases will not participate in any electronic transition. That means electron loss or gain kind of things will not be there with these noble gas elements. Here you can clearly observe 50 A group, otherwise 15th group of elements: nitrogen, phosphorus, arsenic, antimony, and bismuth. Antimony in accordance with IUPAC, it is known as terbium, right? So here nitrogen, phosphorus, arsenic, terbium, and bismuth, these are 50 A group elements, and general tendency to seek 3 electrons, so that octet configuration will be balanced. And when we move on to 6th A, short of 2 electrons by this oxygen family: oxygen, sulfur, selenium, tellurium, and polonium, where 2 electrons will increase the stability of these elements and will attain the octet. And move on to halogen family: fluorine, chlorine, bromine, iodine, and astatine, having strong tendency to seek 1 electron in order to achieve noble gas configuration. Hence, -1 is the generalized valency, or its oxidation number, right? And if you consider neon, argon, krypton, xenon, and radon in addition to helium, they are having NH2 NP6, and these are called highly stable because of magic octet. Because helium is only with 2 electrons, that's why it is not mentioned in this. Here, loss of electrons are the general trends in case of metals, always they are having tendency to release the electron, because by releasing electron they will become electropositive, and moreover it attain the noble gas octet configuration. Sodium, potassium, rubidium, cesium, and francium, these are the elements of alkali metal, and with the loss of one electron octet will be achieved. And second A group, which is also known as alkaline earth metals, magnesium, calcium, strontium, barium, and radium, loss of two electrons will accord the stability for these atoms or elements, so that they are dipositive in nature in general. And the third A group elements, we can say 13th group, aluminium, gallium, indium, and thallium, where trivalent nature will be there and the 3 electron loss, and subsequently they are converted into tripositive cations. All these are regarded as metals. Metals are generally electropositive, and the tendency to lose the electron is the common trend here. Non-metals are electronegative. Tendency to gain the electron is the general trend. Noble gases are neutral, neither to lose nor to gain the electrons. Now, we entered into the question time, where what have to observe for above conclusion about the main group elements. What are called main group elements? S block and P block collectively denoted as main group elements. D block elements are separately identified as transition metals, and F block elements are distincted as inner transition elements, right? Main group elements, what kind of trends we are observing? This answer collected from Brainly. Thank you very much for your valuable information. From the table, it is very clear that chemical reactivity of main group elements mainly depends upon the valency electron count with the respective groups. Based on their group position, their valency electrons will be assigned, and based on the valency electron, their nature will depend. Electropositivity or negativity purely depends upon number of valency electrons present in that. Metals are losing electrons while non-metals are seeking electrons to attain the stability. These are the general trends in the modern periodic table, and ultimately they used to achieve octet by this Lewis and Kossel in terms of electronic theory of valency. Another question was given, why do atoms of elements try to combine and form the molecules? The answer collected from wiki books. Thank you very much for your valuable answer for this. Why atoms are combining to gives rise to the molecule. Atoms come together to form the molecule because of their electrons only. Some electrons are short and some electrons are excess. That's the reason why. In order to get the uniformity, they are combining in order to achieve the stability. Electrons of the atoms come together in two main ways. One is covalent bond formation. Second is called ionic bond formation. Covalent bond formation is possible. The simplest example taken as the oxygen molecule formation, otherwise nitrogen, hydrogen as well. Oxygen, where 2 electrons from each individual atom get shared, total 4 electrons shared among 2 oxygen atoms, so the double bond is originated. Nitrogen, each nitrogen contribute 3 valency electrons, so that triple bond will be originated in between 2 nitrogen atoms in the molecule formation. Whereas hydrogen with 1 electron and 2 hydrogens are mutually sharing 1 electron from each, a total 2 electrons will be shared among these 2 hydrogens, and mono, what we can say, single bond formation is possible in between. So in this manner, based on the valency electron, number of bonds or type of bonding will be possible in between the various atoms and subsequently converted into molecules. But when an atom gives one of its electrons to another, they held together by electrostatic forces. This is another strategy of bond formation, where complete shifting of electrons from one place to another, that is called a transfer of electrons. This sort of bond is known as an ionic bond, and they are held together by, ions are held together by electrostatic forces, because one atom which is losing electron is assigned with the positive charge, which is seeking electron with assigned with the negative charge. These sort of bonds are in acids when you consider vinegar. Vinegar is also known as dilute acetic acid is called vinegar, where CH3COO minus and H plus will be there. That means that kind of a separation of charges will be there. And when we consider bases like ammonium, where ammonia is considered as a covalent bond rather than such ionic bond formation, where nitrogen and hydrogen are sharing electrons. So mutual sharing is possible among two atoms which are binding directly with the chemical bond formation, and they are held together by ionic bond formation. And a sodium usually explosive. So just when sodium kept in the open air, what happens? It will explode. So, and a high amount of heat will be evolved because sodium is a highly, what we can say, hygroscopic in nature, which used to absorb the moisture whichever present in the air. Otherwise, when it is added with a drop of water, even that used to give the high energy outside, that is highly exothermic in nature. And even if you take sodium hydroxide pellets added to water, so that entire beaker becomes warm, because when it sodium hydroxide added to water, heat evolved during the reaction. That's the reason why that is the kind of exothermic. If exothermic reactions are extreme, that means heat evolved is highly extreme, that you can say explosive. So that sodium is not usually kept in the open air, rather we have to store in the preserved regions, predefined conditions like kerosene or diesel. Any kind of suitable solvent is required because it will be stable under such a solvent conditions. And always sodium having tendency to lose the electron, chlorine will seek the electron, so the transfer of electrons and held together by electrostatic forces in between, and reaction is possible. And but sodium, even though it is a highly explosive in nature, and chlorine is also dangerous in the natural state. If we are taking direct chlorine gas, if we are inhaling that one, that also causes so many type of adverse effects. But rather, sodium chloride, that is very essential for the survival of all the human beings, because table salt is made up of the sodium chloride. In that manner, chemical bonding will used to give the stability. Ultimately, they are used to get the noble gas configuration. And noble gases of 18th or 8th A possess 8 electrons in the valency shell of their atoms. Helium is the exception, because helium is associated with 1s2 electron configuration with only 2 electrons, but still it is stable because whatever shells available with that entirely filled, so that it will be the exceptional helium, exceptional noble gas. It is without octet, it will be stable. But whatever shells available, they are completely filled. So this is the conclusion we are getting from this Lewis-Kossel electronic theory of valency. For that theory, we are getting conclusion. 18th group or 8th A group elements are having completely filled electronic configuration, but only helium is the exception among all those. Noble gases with 8 electrons in the valency are highly stable, rarely participate in the chemical changes. Therefore, it is concluded that any species with 8 electrons in the valency shell are highly stable. If valency shell is occupied with 8 electrons, that will be more stable in accordance with the octet rule. That is the main conclusion we drawn from this theory called Lewis and Kossel. And in continuation to that, here is the electronic configuration provided for helium with 1s2, neon with 1s2, 2s2, 2p6, 8 electrons in the valency shell. You can clearly observe second main shell completely filled, argon with the third main shell completely filled, 3s2, 3p6, krypton fourth main shell completely filled with the 4s2, 4p6, xenon fifth main shell completely filled with the 5s2, 5p6 electronic configuration. That is also given individually. Helium with 2 atomic number 1s2 and 2 electrons in their valency shell. Neon with 8 electrons, argon also 8, and krypton 8, xenon, eventually radon also having 8 electrons. Hence, you can see all these are attaining octet except helium, and their atomic numbers and the subsequent electronic configurations also mentioned in this. Now, in extension to that conclusion, it is accidental that first A and 7th A main group elements during the chemical reaction get 8 electrons in the outermost shell of their ions, similar to noble gas atoms. So is it possible to all, or is it only accidental for first group to seventh group elements? Some are losing electrons, some other are gaining electrons. If you consider first A group, I'm taking simplistic sample, sodium converted into sodium monopositive, And the 7th A group element, I'm taking halogen family. Fluorine get converted into fluoride by seeking electron. Is it accidental or actually occurring? So it is not accidental. It is required actually in order to attain the octet configuration. Then eventually they will become more stable. Now, no, it is not simply accidental. 8 electrons outermost shell is a mandatory thing in order to attain the stability. Based on the above observation, the statement known as octet rule is framed. When they are getting NS2 NP6 outermost shell configuration, that is regarded as octet, and then only they will attain the stability. This is the final conclusion we drawn from the all kind of parameters what we discussed. Now we are going to discuss about a clear vision about this octet rule, what actually called octet rule. In order to explain that, first we have the definition for this one. It may be defined as the atoms of elements tends to undergo chemical changes that used to leave their atoms with the 8 outermost electrons. The element with 8 outermost elements are regarded as they are obeying octet rule. That is given as NS2 NP6 configuration. The elements of noble gas family are obeying all these, and the carbon, nitrogen, oxygen, fluorine are showing chemical reactivity in order to reach that octet. Outer atoms are obeying this octet, but not for 100% this octet is employed to all the elements which are present in the modern periodic table, but maximum elements are obeying this. Maximum elements are obeying, not all the elements. That is a simple exception. Now, we are going to discuss where the lack of octet is there and why they are participating in the bond formation. I'm going with the hydrogen, being it is the first group element with 1 electron. In order to reach its nearby noble gas configuration, what is the nearby electronic configuration? Helium. Helium with 2 electrons, so that it has strong tendency to get more 1 electron. So here lack of octet is there. And the beryllium. Beryllium with the 1s2 configuration, right? So here 1s2 configuration is there. That's the reason why what we can say 1s2, 2s2 is there. What we can say more how many electrons are required for this one? More 6 electrons in order to get 8 electrons. 2 electrons are there, more 6 electrons are left. Otherwise, if we lose these 2 electrons, then also it will be more stable. So that it also regarded as a lack of octet. If you go with boron with 3 electrons, then how many electrons more required? Let us consider its electronic configuration. 1s2, 2s2, 2p1. 1s2, 2s2, 2p1 means 3 electrons are there in the valency shell. It is mentioned with the Lewis dot structure. 3 electrons short of 5 electrons in order to reach octet, so that you can say it is also having lack of octet. Carbon with 4 electrons more, 4 electrons are required to reach the octet. Nitrogen with 5 electrons more, 3 electrons are needed to achieve octet. Oxygen with how many? 2 plus 2 plus 2. 6 electrons are there more, 2 electrons to reach the octet. Fluorine with 2 plus 2 plus 2 plus 1. 7 electrons are there in its valency shell. So here 1 electron, it will reach octet. So that all these are termed as a lack of octet, elements with lack of octet. So here all these are having reactivity to achieve that octet, NS2 NP6. Now, let us consider how the chemical bond formation in consent with the octet rule. The force of attractions between any two atoms or group of atoms are stable entity called a chemical bond formation, which are uniting the atoms to converting into a stable molecule. That type of bond formation is regarded as a chemical bond. There are many type of chemical bonds, but we are regarding only ionic and covalent bond formation here. So here sodium chloride is purely ionic compound, water molecule is purely covalent compound. Now we will discuss about these two, how the bond formation is possible. Let us consider sodium chloride. Sodium chloride, how it will be generated? Sodium will give 1 electron, chlorine will accept 1 electron. This is known as transfer of electron, and both are held together by electrostatic forces. And let me consider covalent bond formation where mutual sharing of electrons are possible. Hydrogen with 1 electron, one more hydrogen with 1 electron, oxygen with 4 electrons. 4, 2s2, 2p4. Total 6 electrons are there with oxygen. 6 plus 2, total they will become 8 electrons. If they share electrons, hydrogen is contributing 1. In either hydrogen 1, oxygen with 6. 6 plus 1, total they will become 8. 8 contributed electrons will remain the common property of 2 hydrogens and 1 oxygen because they are mutually sharing. So it will be the covalent bond formation. So that kind of perception will be given. Again, in both the cases, after sharing or transferring, they are attaining octet. That is the importance of octet rule. By this, we completed the session where we discussed about Kossel and Lewis theory. And in addition to that, octet rule is also completed. All these are the part of chemical bonding. Hope this session will be helpful for your preparation. Thank you very much for your consistent listening. Thank you, one and all.